So you have 3 strips of paper. You want to align them so that there's at least a 1/2 inch or so between the 3 colors. Then you're going to fold it over and do the same. So you will have 2 strips in the center that are the same color, but otherwise they will alternate. I should have known it was y'all were going to give me grief about that because you're GT kids. I cut them, but I cut them in a hurry with this paper cutter, which is not a very good one.
Yeah.
Right. So you're folding them so that the flaps are overlapping in different colors. Yeah. Yes, that's good. Now there are these staplers. If you'll take care of them, you can pass these around. I have another one if you want to come and use it at my desk, but you have to leave it at my desk because honestly, I bought staples for all the tables, and within a class period, if they're just passing around the room, they're broken. So this is my good one. That one works for some people and it doesn't for some people, and I don't know why. So either come and use this one, but don't take it from my desk, or wait for the other one to come around. Right? Okay. So you have the overlapped colors in whichever order you want. And then you staple at the top. So you're going to use a straight edge and mark at the bottom of each flap so that you have a tab area to write in. And then this is the general transformation equation on the front. We will use this foldable all of this year and all of next year. Right? So you're going to want to keep it. We will add other types of graphs to it as we go along. So we're starting out with what the general form of the equation is on the front flap, but then the specific one that we're looking at today is the absolute value function, which is, this is the general format for transformations of an absolute value function. So these 2 vertical bars, the 2 vertical bars are the absolute value symbols. Yes, copy that down. And then, go make these, draw the lines at the bottom, across the bottom of each tab, because we don't want to write other things in that area. So what I did is I just used the straight edge of the tab above it to draw these lines across. And then copy all of these labels onto the flaps. So after you've copied all the labels and set up all the tabs, on the first flap, you're going to draw in a graph. Glue in a piece of graph paper. You're drawing the parent function for absolute value, which is at the origin. The vertex of the parent function is 0, 0. And we always refer to this as h comma k. So inside this formula, when you see the h and the k, those 2 values are your vertex. So you can know what the vertex is even without graphing it, because in this format, the h and the k will be the vertex. You should also add this note. See where I put the star or the asterisk? If the function, listen please, if the function is written as bx minus h without the parentheses, then you must factor the b. So you're going, if it's written as bx minus h, you must factor out the b value before you will know what the h value actually is.
B is the y intercept, right?
Not on the. It would be if it were linear. In this format, the b is what's going to tell us the the horizontal stretch or compression and the horizontal reflection. which is the last flap that we'll cover. Does that help make it a little bit darker? Okay, so for this flap, H is a horizontal shift. It's moving left or right, but what you see in the formula, x minus 4, is moving right because the H value is 4. X minus is part of the formula. When the H value is negative, so when H is negative 2, it's going to go left, but what you see is x plus 2 because we don't write minus the minus. We write plus.
How come they do that? Why do they make it inverse? Why can't it just be normal?
Because people want things to be complicated.
It's because the formula itself is the x minus, and then you're putting in the H value. The next value is K, is also very simple. This one is very straightforward. K is vertical shift. It moves up or down, and it's exactly what you see. If you're adding, you move up. If you're subtracting, you move down.
So it's not inverse.
So it's not inverted, right? Plus moves up, minus moves down. The A value has several things that it does. Okay. First, if A is negative, that's what A less than 0 means. If A is negative, it reflects it across the x-axis. So this is a vertical reflection across the x-axis when A is negative. If the value of A, which is why I have the absolute value marks there, if the value of A is greater than 1, it vertically stretches by a factor of the value of A. So if there's a 2 in front, it's going to vertically stretch by a factor of 2. If the value of A is between 0 and 1, it vertically compresses by a factor of the value of A. So I don't know how well the colors show up, but I have an orange one here with the negative. That's this one, which is reflected. The blue one is multiplied by 4, so it's a vertical stretch. It's vertically stretched by a factor of 4. That's the skinny one here. And then the brown colored one here is 1/2 of the absolute value of x. It's vertically compressed by a factor of 1/2. So the A value reflects, stretches, and or, that's supposed to be a slash right there, and or compresses. It might reflect and stretch, or reflect and compress, or just stretch, or just reflect, or just compress. Vertically. So the A value is vertical. So when B is negative, it's less than 0. It reflects across the y-axis. When B is negative, it reflects across the y-axis.
That was the last one, right?
This is the last flap. Is that what you're asking? The value of B, when the value of B is greater than 1, now please take note of this before you write it. Oh, it doesn't reflect. That's what I get for using it. It horizontally compresses. Boy, I didn't leave enough room. It horizontally compresses. When the value of B is between 0 and 1, it horizontally stretches. Now, notice that this is the opposite to A. When A is bigger than 1, it vertically stretches. But when B is greater than 1, it horizontally compresses. When B is between 0 and 1, it stretches, but when A was between 0 and 1, it compressed. So these are reversed.
We're having a minute to lunch.
Okay, we'll pick up with the rest of it after lunch. I have an activity if we get it finished. Otherwise, you'll just do your exit ticket. No cap.
I knew you were going to say that.
Okay, hang on just a minute. It's not quite 12:35 yet. Okay, now it's 12:35. Enjoy your lunch. All right. It's just going to be here.
Wait, we just play this person back.
Why don't you do a little eye trick? When you put it right down to your eyes. Like that actually, like, does that work?
Enjoy your lunch. Okay, so we have, when B is negative, it reflects across the y-axis. When the value of B is greater than 1, it's horizontally compressed. And I forgot to write by a factor of B. When the value of B is between 0 and 1, it is horizontally stretched, or it horizontally stretches by a factor of B. So then we're going to do 3 examples. Now, the thing about this one is if this isn't moved left or right, you can't tell the difference. Okay? So it would be better if I gave you one that was shifted. Because it looks the same, right? Just like a parabola if you reflect it across the y-axis. So let's do... Make sure I have it right in my head. Well, I'll go ahead and do the 3 that we're supposed to do. So this one is reflected across the y-axis. Then we're going to do y equals 2 x. So when x is 1, we multiply it by 2. Then we take the absolute value. So we're going to go over 1 and up 2. When x is -1, we multiply it by 2 and we get -2, but then we take the absolute value. Okay, would you bring in the doorstop and close the door now, please?
What? What are you complaining about? Then? Then?
Can I get it out, please? I was gonna check on you because you kind of hit the wall instead of the doorway.
Because I told him I'll get them. I told him
Rapper names Big Sam. I'm Lil Come Shot. Big Sam. You know the brown thing, everybody that does
No. Make that noise when you're hitting hard.
Where do they all say that?
Where's the little crabs?
Did you run out on your table?
No, I lost one.
It's
I
already
think somebody took it.
$30 yours.
Oh.
Thank you.
Wait, what? Would you get some?
Me?
Yeah.
Okay, bro. Come
Tossing the football. They're tossing the football. What's she throwing it? He's tossing it.
How can you speak, huh?
So these are all the things with the b value. But the blue one is the reflection across y, but it looks exactly the same as the parent function because it's symmetrical across y. So when you reflect it across y, it still looks the same.